Hi, my dear students. Welcome you all. Welcome to Unacademy. This is your B V Reddy sir. A great news to all of you. So, as you might be know, in GATE 2024, Unacademy students have performed extraordinarily. You can have a look at now. 7 AIR 1 ranks from Unacademy students only. Now it's time for you can start your serious preparation with Unacademy to achieve your dream goals. And you can see this thing: electrical, computer science, ECE, CH, IN, PI, NM, all these branches, the toppers from an academy only. Right now, you can start your serious preparation with an academy to achieve your dream goals. इसके लिए हमने आपके लिए लेकर आया फ्लैट 50% of discount as the request of the students. We have extended this offer up to 28th August. We have extended this offer 28th August तक हमने extend किया ये offer. So utilize these opportunities and you can use the code of BV Reddy to get the great discount and personalized guidance from me. So you can find the top educators in the single frame. Now flat 50% of discount. So here, so plus subscription 8,499 and iconic carry 11,999. So you can start new batches. We are starting. You can start your serious preparations. Chelo, you can have a look at now here. I'm going to start the EMT subject. Going to start from the 25th August. So you can enroll for these batches to have a great learning experience. And these are the list of books electrical students can able to get. EMT, networks, electrical measurements, digital, electrical machines, power system, power electronics, analog, signal system, control system, mass, aptitude. All these books you can get to delivered to home address within 15 days of your subscriptions. These are the ECE books. These books will be given to the iconic subscription students only. चलो आज का सेशन हम शुरू करेगा. Previously we have completed the 40 problems we have finished. एक बार we can see those problems now here. We have completed. So let's continue our problems. All these problems previous class we have discussed. You can have a look at now. Take this problem one by one problem. The RMS value of the current I is equal to 3 plus 4 into sine omega t plus pi by 4 is. They given this current which is given as what? 3 plus 4 sine of omega t plus pi by 3. For this we need to do this as a RMS value. The RMS current which is given as what? Tell me. 3 square plus 4 square by 2. So that is given as what? You tell me now. 9 plus 16 by 2 means 8. So which is equal to root 70. Next one. The peak value of an alternating EMF is given. So amplitude is given as a 10 volts. Frequency given as 50 Hz. So they given E0 value, how much you tell me now here? 10 volts. And frequency given as 50. From this we can find the omega value is what? Tell me now. 2 pi f. So that means which we can say 100 pi radians per second. So from this we can write the voltage expression. V is equal to E0 is 10 into what I can say? Cos of 100 pi t. Now from this we can say instantaneous value EMF when t is equal to how much? 1 by 600 seconds. So from this, so E is equal to what? You tell me now here? 10 into cos of 100 pi into t value 1 by 600. So that is E is equal to 10 into cos of what will be now pi by 6. So that is E is equal to what we can say 10 into cos pi by 3. Cos 30 value root 3 by 2. So that's why E is equal to how much you tell me now 5 root 3. Next. The voltage of an AC source varies with time according to equation. So they ask him to find which will be the correct option. So V given as what, tell me? 100 sine of 100 pi t into cos of 100 pi t. So this V, which we can say this as 50 into 2 sine of what, tell me now here? 100 pi t cos 100 pi t. So you can tell me this thing. So from this E is equal to 50 into this is sine 2 theta form, sine 200 pi t. This is the V value. Now, so how much the peak value, tell me? Peak value, this is V naught, which is equal to 50 volts. And omega value, how much? 200 pi. So this means frequency is what, tell me now here? 100. So comes option correct? C. Next. An alternating voltage is given as like this. They ask you to find RMS value. Yes, E given as what, tell me? E1 into sine omega t plus E2 into cos omega t. Since sine and cos are orthogonal to each other, so directly we can write RMS value, which is what, tell me? E1 squared by 2. There is no common area between sine and cos. The orthogonal value sine theta cos theta is an orthogonal. That's why directly we can write the formula. And AC voltage is given by the mean value of voltage calculated over time interval of t by 2. It can be 0, but we cannot say absolutely 0. It may be 0. Next, AC voltage is given applied across a DC voltmeter reading. Voltmeter reading, DC voltmeters will measure the average values. DC voltmeter measure average values. So that's why the average value of sine or cos is how much? 0. So the voltmeter reading is what we can say terminal here, which is equal to 0. A 0.21 H inductor and 88 ohm resistor are connected in series to a 220 volts 50 Hz AC. The current in the circuit and the phase angle between the current and the voltage is. Okay, they given, so the series circuit of a resistor and they connected the inductor, they connected. So this is R value given as what terminal of 88 ohms, and this inductance which is given as XL value we need to calculate. How much the supply terminal of 220 volts, frequency is 50 Hz, and they asked him to find this current. Okay, now, so what is this XL value? Tell me now. XL is equal to omega L which is equal to omega is equal to 2 pi f is a 50 into L is what, tell me now here, 0.21. So this means what we can say now, 100, 21. 21 pi means what we can say, 22 by 7. So this value 7 3 is now 66. Right. Now Z is what we can say now here, square root of R squared plus XL squared. So that is Z is equal to square root of R squared. R is how much, you tell me now, 88. 88 squared plus XL, that is 66 squared. So do simplify this thing, how much will come, under root of 88 squared plus 66 squared. How much is value? Z value 110. Z is 110, so this current is equal to 220 now V by Z, which is equal to 2 amps. Then from this, we need to find phase angle also now. That is, phase angle is given as what? Phi is equal to tan inverse of XL by R. So phi is equal to tan inverse of XL is a 66 by R is 88. So phi is equal to what we'll get now here. So tan inverse of this is 3 by 4. Option A. Next one. In an AC circuit, the potential difference across an inductor and resistor joined in series are respectively. The potential difference across the circuit is, they given as what terminal, inductor voltage 16, a resistor voltage that is given as 20. So V is equal to what terminal, square root of VR squared plus VL squared. So that is V is equal to square root of, so this is 20 squared plus 16 squared. So simplify, how much will come here? Square root of 20 squared plus 16 squared. So this value 25.6. Next one. When 100 volts DC is applied across a solenoid, a steady current of 1 ampere flows in it. When 100 volts AC is applied across the same solenoid, the current drops to 0.5. Okay. So here the two cases are there. Case 1, they did what, tell me now, 100 volts DC. Case 1, 100 volts DC. When applied, the 100 volts DC applied, so which is a resistor as well as a inductor is present. And this they given as what, tell me now, resistor value we don't know, and this XL value for DC, XL is equal to 0. How much this is? 100 volts, and this current is I, if I say, which is equal to 1 ampere. Now, so the impedance Z, which is given as what, tell me now, V by I, which is equal to what, tell me now, 100 by 1. So this is 100 ohms. Now, so same thing, Z is equal to, we have the other formula is what, tell me, R squared plus XL squared, na? R value. So from this we can say XL is equal to 0. So from this R is equal to 100 ohms only. This is a case 1. Now case 2, what they did now here? So now they applied the 100 volts AC, they applied. 100 volts AC applied. When they applied 100 volts AC, now in this case capacitance reactance is non-zero. Why? Because frequency is non-zero on some finite value. resistance value 100, and here we have XL we have, and this is 100 volts AC now here. In this case, this current is given as what tell me now 0.5 amps. So the Z is equal to what you tell me now here 100 by 0.5, which is equal to what tell me now here 200 ohms. That is Z, which is equal to square root of what I can say now here R square plus XL square. So this is 200 square equal to R square, means what tell me now 100 square plus XL square. XL value we don't know. We need to calculate. So from this XL square, which is equal to what tell me 200 square minus 100 square. So this XL square, which is what tell me now 200 plus 100 into 200 minus 100. So how much this XL value tell me? So this is 300 into 100. 300 into 100, then under root we have taken, so this is 100 root 3 XL value, and frequency given as what tell me, this is the frequency, which is frequency is omega L XL value, that is 100 root 3. Omega is equal to 2 pi into 150 root 3 by pi into L, which is equal to 100 root 3. Now check for cancellations now here pi, so this is 300, so this value what tell me now here 3. So this value 3, so this is L is equal to 1 by 3. Option A. Next one. In a purely resistive AC circuit, the current, in case of purely resistive circuit, current is in phase with the voltage. Voltage current are in phase in case of a purely resistive circuit. In a circuit, the inductance is 0.1 and resistance is 1 are connected in series to AC source. The phase difference between the current and the voltage is, here tell me now, phase difference phi, which is given as what? Tan inverse of XL by R. So that is phi is equal to tan inverse of XL is equal to omega L, that is omega L by R. So that is phi is equal to tan inverse of XL value how much? Omega L, omega value 10, L is what element of 0.1 by R. R is what 1. So that is phi is what I can say now tan inverse of 1, which is equal to pi by 4. Option C. In an AC circuit, a capacitive reactance 5 microcoulombs has a reactance of 1000. The frequency of AC is, so that is Xc is equal to 1 by omega C. Xc value given as 1000. Xc value 10Q, that is omega is equal to 2 pi F into C. We need to get the F value required, so that is 1 by 2 pi into 10Q. Capacitance value how much? 5 into 10 power minus 6. So this is F is equal to what we can say 100. So this is what we can say now 100 by pi hertz. Okay, cycles per second is nothing but hertz only. A capacitor of capacitance 100 microfarads and a resistance of 100 ohms is connected in series with the AC supply. The current leads the voltage by that is current leads the voltage by phi, which is equal to what I can say tan inverse of Xc by R. phi is equal to tan inverse of Xc 1 by omega Rc. So that is phi is equal to tan inverse of 1 by omega value is 100 pi. Yes, 100 pi. R is equal to 100 and C value, what tell me now here? 100 into 10 power minus 6. 1, 2, 3, 4, 5, 6. 6 zeros cancelled. So then phi value, which we can say this as, what tell me now here? Tan inverse of 1 by pi. In a AC circuit, decrease in impedance with increase in frequency indicates the decrease in frequency. Decrease. So here, yes, impedance, decrease in impedance, increase in frequency. So if we have taken it as an RL circuit, the impedance is given as what, square root of R square plus omega L whole square. As frequency increase, then impedance is also increase. For this RC circuit, then Z is what, tell me now here? Square root of R square plus 1 by omega C whole square. As frequency increases, impedance value decrease now. So that's why RC circuit. For only resistor means it remains constant. A 200 ohm resistance, 1H inductance are connected in series with AC circuit. The frequency of the source is 200 by pi. Then the phase difference between voltage and current is phase difference between voltage and current they are asking. Phase difference phi, which is equal to what I can say? Tan inverse of what? That is X L by R. So that is phi is equal to what I can say? Tan inverse of XL is equal to omega L. So that is XL omega equal to 2 pi F, 2 pi into 200 by 2 pi into L value 1. So this is 200. So this is 200 by 200. So this is pi is equal to, that is 1 pi by 4, 45 degrees. Next. Now phase difference between voltage and current is pi by 4. If the frequency given as a 50 Hz, phase difference is equivalent to time difference of, yes, phase difference, which is equal to what, tell me now? 2 pi by capital D time period into time difference. Okay, phase difference, which is given as what, tell me now? Pi by 4, which is equal to 2 pi. 1 by t is equal to frequency into time difference is delta t. So pi cancelled. So this means delta t, which is equal to 1 by 8 into F now here. 1 by 8 into frequency is 50. So here that is 1 by 40. So this means delta t will come it as what, tell me now? 2.5 milliseconds. A student connects a long air core coil of manganese wire to a 100 volts DC supply and records a current of 25 amperes. When the same coil is connected across 100 volts 50 Hz AC, current reduces to 20. The reactance of the coil is. Okay, here are just two cases problem. Now first case, now they connected the DC supply, 100 volts DC. When they connect 100 volts DC, only resistor is present now. That is R is equal to Z, which is nothing but what terminal V by I. So how much is value? 100 by 25, which is equal to 4. Now they connected what terminal? Second case, they did the 100 volts AC. In this case, impedance means what terminal here? Z, which is equal to square root of R square plus XL square, that is nothing but V by I. How much is value? Now this voltage is 100 volts and then current is given as a 20. So this value which is equal to 5. Now that means Z is equal to what terminal? Square root of R square plus XL square. So Z value, which is what terminal here? This is 5 square, equal to what I can say now? 4 square plus XL square. So XL is equal to what terminal? 3. Next, a bulb and a capacitor are connected in series to a source of alternating current. If its frequency is increased while keeping the voltage of the source constant, then the bulb, what happens now here? Capacitor, they're saying the frequency is increased. Tell me now here impedance for the RC circuit, R square plus what? Tell me now, 1 by omega C whole square. As omega value increases, the impedance value decreases. So that means impedance decreases, current will increases, power will increases, intensity of the bulb increases. Bulb intensity more. Next, the voltage across the inductor is given. They are asking to find the current. Voltage, if we observe here, V is equal to the form of V naught into, this is a cos now, cos omega t. Voltage across inductor, V is equal to L into di by dt, right? We need I means what I can say 1 by L integral of V into dt. So simplify this thing here. I is equal to 1 by L integral of V means V naught into cos omega t into dt. Integrate this thing here. So that is V naught by L cos integration is sine omega t by omega. So this is nothing but V naught by omega L into what? Tell me now? Sine omega t. So from this, what I can say? What we can say? Tell me now here. This is current in the form of sine wave. So which option can be satisfied? Option D. Next. An EMF is given, is applied to a LR circuit of inductance is given 3 and resistance of 4. The amplitude of the current in the circuit is inductance is given, so this means XL value, how much you tell me now? Omega L. Omega is equal to 10 cube and L is what? Tell me now? 3 into 10 power minus 3. So XL is equal to 3. Now the impedance is what we can say now here? Square root of R square plus XL square. So that is Z, which is equal to square root of what? Tell me now here? So that is 4 square plus 3 square, which is equal to 5. Now tell me now, amplitude means peak value. Peak value of current is what? Tell me now here? V naught by impedance. How much the V naught value given? 4 by Z is 5. So how much is I naught value, peak value? That is 0.8 amperes. Option D. Fine. Right. Okay. Yeah. That's for the today's sessions. And we'll meet in the next class. See you. Bye bye. Take care.